So good day, I am Eric V. Hernandez and I'm going to discuss to you the finals part 2 of Unit Operations 2. Instructor Professor Evelyn Laurito. Moving on to the problem. So I prepared hindered settling problem. The problem reads: particles of a certain cement brand settles through a suspension. The specific gravity of the cement in the liquid are 3,000 kg per meter cube and 1,250 kg per meter cube respectively. The diameter of the cement is 0.06 mm and the volume fraction of the cement in the liquid is 0.3. What is the settling velocity of the material if in the case it is in a hindered settling motion? Viscosity is given also to be at 0.0095 pascal second. So the solutions part. So first, find the velocity and check if it is correct. So normally the hindered settling problem is always assumed to be in the Stokes range. So if the answer is less than 1, it's in a Stokes range. So the assumption is correct. So Vt. So first find for the velocity. So Vt is equal to dv squared times Ae. This Ae is just equal to g sub c times quantity times density of the particle minus density of the solution all over 18 times viscosity. So I get an answer of 0.0036 meter per second. And then we now check if the Reynolds number is less than 1. So this d is equal to the diameter of the particle, and this v is just equal to Vt, and then this p is equal to the density of the solution, and then all over viscosity. Then I'll get an answer of 0.2842 value of NRA. So it's within the Stokes range. So the assumption is correct. And then solving for the hindered settling, so the formula to be used is Vs is equal to Vt, which we have solved earlier, times porosity raised to m. So m is found in the handbook using the NRA. We will able to locate for the m in the graph. So based from the graph, I'll find the value to be 4.4 based on the NRA. So just go to the particle dynamics section of your handbook, and then from the figure 6.58, so this is the graph, and then just locate the Reynolds number at the bottom at the x-axis, and then locate there, just touch the curve, and then locate to the x-axis the m. So we will have the value of m, which is equal to 4.4, and then solve for Vs. In there you have your hindered settling velocity. Moving on to the next problem. So it is about the batch and the continuous settling. So given the following data of your senior instructor from a laboratory batch sedimentation test, find the diameter of the tank needed for a 3 cubic meter slurry with a concentration of 5 kg per meter cube. If it will take about 3 days for the solids to settle to a height of 45 of the original height. If in the case it occurs in a continuous operation having feed rate of 3 meter cube per hour, same concentration, flow rate of 2 meter cube per hour, and the underflow concentration is 10 kilogram per meter cube, what is the area of the thickener? So this is the data given by the instructor. So the time is 0, 10, 20, 30, and 100. And then Z, which is this is the distance, the height of 16, 20, 815, 8, and 2. Then this is the discussion for the batch settling. So ZO will be equal to 16 because this is the initial point, and Z infinity is where you will see there the graph. It will go continuously at that point. The line goes constant, and then Z is just at any time. So we pick this time 10, so the height is 12, and then the critical is where the line suddenly curves. So its value is 8.25 cm at AC is equal to 25 minutes. So just using the formula, so ln is equal to Z minus Z infinity all over Z critical minus Z infinity is equal to K times TC, which is the critical time, minus T. So just plug in the value, so we will have the value of K, and then using K in this problem we will now be able to find for the value of the T. So T will be 30.87 minutes. So this is at the 45% of the original. And then by ratio and proportion, so 0.45 times 16, which is the initial height, and then divided by 30.87, which is the time. So we will have the corresponding value of H. So it is equal to 10.0758 meters. And then using the continuous settling, prior to the question earlier, we will use the Talmadge and Fitch method for this one. So we are given of CO 5 kilogram per meter cube, LO, so it is just the feed, so 3 meter cube per hour, and then CU, which is 10 kilogram per meter cube. So this is the underflow. So note, small mirror will be used in order to determine the intersection of the graph in the graph. So here I've made a graph using via Excel. So these are the values. We just plot it there, and then first things first, make a straight line passing through the initial height. So make a straight line there going down here, and then we have the value of 8 of this ZU, and then just make a line there. So you have an intersection of the line that you made from that 16 and from this 8 centimeter. So you will have an intersection there, and then get a protractor and then measure this the angle that they will make, and then get get the angle bisector of that angle, and then I found this to be the angle bisector. And then after that, so the angle bisector will intersect this curve, as you will see. So that point, make a tangent line there. This one, this will be the tangent line. And then after that, this tangent line will intersect 8, the ZU, which has the value of 8 centimeter. So the intersection of the ZU and the line here, the point, then project it at the x-axis, then you will able to find for theta u, or the time. So the time will be 23 minutes. So the question, so we will now able to find for the area of the thickener. So A is equal to LO times theta u divided by ZO. So just if there are necessary changes for the units, so just apply this one. Just change the units so that you will have a homogeneous unit. So the answer will be 7.1875 meter squared. There you have it. So next one is finding for the pressure. So given the data for the company of Shimadzu prior to the equipment design of the filter was given at 25 degrees Celsius with a viscosity of 0.0095 pascal second, are reported as follows. So you are given alpha 2 times 10 raised to the 11 meter per kilogram, area which is 0.05 meters squared, the CS, or the mass of solids, divided by the volume of field plate, is equal to 25 kilogram per meter cube. So calculate the pressure difference in the system. So given the pertinent values and then the data, so the data, this is the given data. So the time is in seconds, and then the volume is there.